Welcome to the end of Chapter 8. That's been quite a journey dealing with quadratic equations, their solutions, their word problems, the parabolas, the max-min stuff. This last one is really just kind of it's a skill that's indispensable in later math classes. That's why we teach it here. Those of you that aren't traveling any farther in math, well, you have to bear with it. What it is, though, is it's a straightforward kind of mechanical process that we use in order to determine where a function is positive or negative. Okay, there's this fact that if you've got a function floating along, okay, all right, let's go there, and I've got this function doing this. The interesting fact about these polynomials is that where the function, call this f, this is where f of x is 0. It's an x-intercept. But notice what happens on either side of it. On the left-hand side, the function dips below the x-axis and so is negative there. All the function values, you read over, it's negative. You read over, it's negative, okay? But on the other side, what happens, not always, but typically, is you have this whole region here where it's positive. So you read over positive, positive, positive. The function's positive there. So the idea is to use that to our advantage and go, you know what we'll do is we'll find the zeros, and then we'll test the intervals on either side to see if it's positive or negative, because the problems are going to look like this right here, okay? So I have some information. I say, find where the function's 0, plot these on a number line. We're going to do that, and then test each subinterval. If the function's negative, the function's negative on the entire interval, like I was saying up here. And if it's negative, if it's positive, likewise. And then you just write down your answer. So it's pretty straightforward. People tend to get tired and not study this well enough. And really, it's just a matter of doing it. So what I tell students to do, all right, we're going to work on this one now. We're going to do 3 or 4 examples. I think 4. X squared minus 5x minus 14. When is it less than 0? That is negative. Do you see why I'm writing negative there? It's less than 0. That's our question. Okay, so step 1, okay, you can cheat though, by the way. I'm going to say this. Okay, that's an upward opening parabola, isn't it? It's opening up like that. If it crosses the x-axis, look at what you've got. You got a couple of positive areas, and you've got the notorious negative guy in between. Okay? And since it's looking negative, it could be one of these cases. I'm just saying you can use more than just the mechanics to figure this thing out. All right, so the mechanics look like this. Number 1, set this guy equal to 0. This is the only quadratic we're going to do, so pay close attention. Okay, and then solve, because we're looking to see where it crosses the axis. See? And in this case, it's 7 and 2, so yeah, x minus 7, x plus 2. And what I say for step 2 is throw out a number line and mark these guys. X is equal to 7. Forgot to say that x is negative 2. So I'm going to put a mark here at negative 2 and positive 7, and I'm going to test the intervals. I have a question for you, though. Should we include minus 2 or 7, and why or why not? Look at the inequality. That's what we're really trying to solve now. Okay? In fact, I'll write it over here, but I'll write it in factored form. X minus 7, x plus 2. When is that less than 0? That's what we're trying to figure out. Did you see the thing that I said less than 0? Not less than equal to. Equal to 0 is no good. Equal to 0 happens when x is 7. I'm putting an open circle there, you know why? And also negative 2. We don't want 0. The problem says, don't give me 0. Okay, we won't give you 0. So we'll exclude minus 2 and 7, because when we plug in minus 2 or 7, we get 0. How do we know? Because we just solved it. But now what we do is we go in between these zeros, and we test these intervals. This one, and over here too. How do you test them? Well, according to what I've written up there, choose a number. Like choose, let x equal over here, I'll just choose negative 3. He's right there. Okay? And plug it into your inequality. Okay. So the inequality I like to use is the factored one. So when I do that, negative 3 minus 7. And then negative 3 plus 2. Is that less than 0? Let's find out. So we go minus 7 and plus 2. Well, this is a negative 10 times a negative 1, which is actually a positive 10. And is it less than 0? No. So that interval is actually positive. In fact, it's kind of cool to do it this way too. We do this in calculus. We just go, hey, that's a positive interval right there. But we don't want positive, we want negative. Okay, so we go to the next interval and try it again. So in this case, let's let x equal between these two. Oh, I always like to use 0 if he's available. So I plug in 0 minus 7, 0 plus 2. Is that less than 0? This is minus 7 times 2, and it's minus 14. And of course, yeah, that's less than 0. This time it's a negative interval. We want negative. Uh-oh, we better lay claim to it. Boom. I just graphed the solution right there. Now, you may or may not want to do this one. You might think you know the answer, but I'm going to do it anyway. Let x equal 8. Okay, 8 minus 7. 8 plus 2. Is that less than 0? This is 1 times 10 is 10 less than 0 again, I say. No. So this one was good, but the ones on the wings were not, because it's positive. So our answer is what you're looking at right there. If they ask you to graph it, you're done. If they ask for interval notation, well, you get one more step, right? But the main thing is, how do you do this? Okay, so our answer, negative 2 to 7, is that. Done. Again, find the zeros, check the intervals, and if it's what you want, you shade it in. If it's not, you don't shade it in, and that's your answer. Okay? I don't know, man. Okay, let's do another one. This is a polynomial one. It's going to be kind of tedious, but I grabbed it from the book, and it says, and my math lab assignment has this in it as well. So we're wondering when this product right here is greater than or equal to 0. So we're going to say this. It can be positive is good or 0 because of this symbol right there. So let's rewrite it. We've got 4b plus 3 times 3b minus 2 times b plus 2 greater than or equal to 0. Well, if this were multiplied out and they gave this to us, we would have b cubed. We don't know how to factor that thing, okay? So thankfully it's been factored for us. In a later math class, we learn how to factor and figure those guys out. And it's involved. You got to do some stuff to it. But certainly I could teach it to you and you'd be able to figure it out. It's no problem. It's just, it's more steps. Okay. We, number 1, set it equal to 0 and solve. Well, this one's given to us on a silver platter. The first one is b is what? Negative 3 over 4. Second one, b is equal to positive 2 over 3. Third one, b is equal to negative 2. So you bring out the number line and you mark them off. Should we include these guys? They make it 0. If I plug in negative 3/4 right here, I get 0 times whatever. It's already factored. Do we include them? Look, yeah, why? Symbol. It says less than or equal to 0. Okay. So the farthest to the left I'm thinking is minus 2. There he is. And then pretend this is minus 3/4. And over here somewhere is positive 2/3. And it's a matter of just testing those intervals again. So you're going to pick numbers from each. An easy one here for this interval might be x is negative 3. If you keep going, okay, let me pick my guinea pigs here. This could be x is negative 1. This one, of course, x is 0. And over here, maybe x is 1. So I'm just picking numbers that are in between. Negative 3 is here. Negative 1 is here. 0 is like here. And 1 is right here. Okay, we're picking these numbers in the intervals. And we have to plug it into this guy. This time what I'm going to do, in fact, I'm going to write this whole thing down here so I can see it better. So 4b plus 3, etc. This is how you can get a little bit faster on this thing. You're really just interested if it's positive or not. So what you can do is cheat a little and go, Okay, what happens, I'll put this underneath. What happens if I put a -3 here, -3 here, -3 here? Can I figure out the signs? This is -12 plus 3. That's definitely negative. This is -9 minus negative. And this is -3 plus 2, just barely negative. So what happens when we multiply three negatives together? We get negative. So this region is negative. And negative, we know likey, we want positive. Okay, that one doesn't make it. Go to the next one. A lot of students go, you know, I bet this one's positive. Well, don't bet your life on it, because sometimes we're in for surprises. I'm going to roll this up a little bit more. What if we plugged in, you know what, I'm going to just erase and do this again. What if we plugged in this time, what was it? Okay, -1. What do we get in that case? Now let's see. -4 plus 3, negative. -3 minus 2, negative. Okay, here we go. Uh-oh. What did I put in there? That's supposed to be a -1. -1 plus 2, positive. Aha! Negative times a negative is positive times okay, this one's positive. And we like positive. So we say, there's my solution, part of it. You go to 2 more sections. You following this? Do it. Pause and do and see if you get it right. People in a hurry kind of mess this up, so you just deliberately do it. Plug in 0, right? That's what we're plugging in next, is that right? This guy? We already did these two. So 0 and 0 and 0. This is just 0 plus 3 is positive. 0 minus 2 is negative. Boy, he stays negative. 0 plus 2 is positive. This time it's a positive times a negative times a positive. A single negative makes you negative, and we don't want negative. You're right, it flip-flops, but I'm going to check just to be sure. The next thing I'll do is plug in the 1. Okay, this is the last one to check. All right. So let's plug in 1. 1 here, 1 here, 1 here. That makes 4 plus 3, that's positive. Look at this one finally. 3 minus 2 is positive, and this guy is positive, so the whole thing is positive. This is positive. Are you positive? I'm positive that it's positive. So this part is also a solution because we wanted positive. And 0. Okay? So you're looking at the solution. If you want to write it in interval notation, it would be what? I bet you know. It's -2 to -3/4. And if you want to put a union, that's fine. And then 2/3 to where? Infinity and beyond. That's the solution right there. Okay, so that was a polynomial type. The last kind is rational, and that deserves a little more explanation. So here we go. We're going to fit this all in one video, hopefully probably 20 minutes. Okay, these are the rational ones. These are also in the homework, and to be fair to you guys, I figured I'm just going to do them so you can see how to do these guys, of course. The thing about rationals is, I don't think we've graphed this. So you don't know about the graphs of these things, but I'm going to fill you in a little bit. In the numerator, if a is equal to 1, we get 0 over whatever. You get 0. Likewise, if a is equal to 7. So let me show you this. If a is equal to 7, we get 7 minus 1, 7 minus 7 over 7 plus 2. That's equal to 6 times 0 over 9, which is 0 over 9. Well, that's 0. So the ordered pair, if you plug in 7, you get 0. Now, we're not graphing, but I want to show this to you graphically. So if you trust me and say, yep, I have a 0 at 1, and yep, I have a 0 at 7, this bottom guy, if you plug in -2, if a is -2, you get, okay, downstairs 0. What do we know about dividing by 0? It's no good, Nick. Something you don't know, but I'm going to put it in anyway. -2, you have what they call a vertical asymptote. Okay? And a vertical asymptote, the curve cannot cross it. So you could have something like this or whatever. Suffice it to say that if you plug in -2, it's a problem. Okay, so let me start over with this one and say this is how I would attack the problem. Okay, and then we have one more after this. So we have a minus 1, a minus 7, all over a plus 2, and we want to know where it's greater than or equal to 0. We do everything the same. It's just that when you look upstairs, the zeros upstairs are the x-intercepts. But the zeros downstairs are what I call the vertical no man's land, the asymptotes. Okay, that means for you guys when we're doing the homework is just find where it's 0 in all the factors. So upstairs a minus 1, if that's 0, we get a is 1. A minus 7 is 0, okay, a is 7. And this is where the rational expression is equal to 0. However, downstairs, a plus 2 is equal to 0, so we get a is -2. This is where it's undefined. Our problem, if you go to it, look at right here. We want positive, and see that line underneath? We want equal to 0 also is okay. Okay, so now we're going to do our number line. Oh, we ran out of room already. We're going to do our number line and test it, okay? So we're going to write it all out. And the numbers we found were -2, 1, and 7. Remember the graph up there? So here's -2, here's 1, and here's 7. Okay? So do we want -2? No, it's undefined. You can't even plug -2 in. It can never be a solution. If you come from downstairs, you know how it is. Nobody wants you. So -2 is no good. But if you're from upstairs and equal to 0 is what you want, then yeah, you guys are good. But if it were equal to 0, not good, if it were strictly greater than, these guys would be excluded as well. You understand? You don't want 0. So I'm not going to do all the work here because this is a long video now. But what I would say to do is let's test x is -3. I know. X is equal to, say, 0. X is 2. And maybe over here, x is 8. And I can do it really quick by looking at the numbers. This is how I do it. -3 minus 1 is negative. -3 minus 7 is negative. And downstairs, -3 plus 2 is still negative. The whole thing is negative. I'm just going to keep that under wraps, okay? We don't want that. We want positive. Now I'm going to plug in 0. I'm looking up here, okay? 0 minus 1 is negative. 0 minus 7 is negative. 0 plus 2, guess what, is positive. These, with an even number of negatives, is positive. Let's go with 2. 2 minus 1 is positive. 2 minus 7 is negative. 2 plus 2 is positive. The whole thing is negative because there's a single negative there. And then finally, 8. Guess what? Plus, plus, and plus, right? Positive, positive, and positive. This guy is positive. What do they want? They want positive, right? There it is. So they want this interval and also way over here, this interval. So in interval notation, we'd say -2 to 1, union 7 to infinity. Okay, that one's done. Now, this one I know you'll have a question on. You can certainly look it up. I'll just do a couple steps on this one to show you. If it's not 0, then I can't play the sign game. You know, is it positive, is it negative? Here's what you do. You ready? It's pretty cute. Bring the 1 over as a -1. Ah, there's 0. And now you got to do a game called common denominator. Multiply top and bottom by x plus 2. Yes, there's a little bit of extra work here. You get 5 over x plus 2 minus x plus 2 over x plus 2. That's less than or equal to 0. So you end up with 5 minus x minus 2 all over x plus 2 less than or equal to 0. Or, what would that? 3 minus x over x plus 2 less than or equal to 0. It's very easy to see that upstairs, if x is 3 is a thing, and downstairs, if x is negative 2. The negative 2 comes from downstairs, the 3 comes from upstairs, and in the problem, you want negative or equal to 0 is okay because of the line underneath. So when you go to 3, color it in, it's wanted. I can finish this off. So what I would do here is x is negative 3, and in here x is 0, and in here x is 4. So when we plug in negative 2, right here, you got a positive, oh, I don't want negative 2, negative 3. You got a positive over a negative, so the whole thing is negative. And then when you plug in 0, of course, you got positive, positive. So the whole thing is positive if you plug in 0. And if you plug in 4, you got negative over positive. Going fast, huh? So that's negative. What do they want? They want, what did I write down? Negative or 0. So the negatives win this time, and we want that guy, and we want that guy. And the intervals are minus infinity to minus 2, close parentheses now, union bracket 3 to infinity. And there you go. Boy, I didn't think I was going to squeeze that in. That's a long one, but the mechanics are the same throughout. There's a lot to know there. All right, that's it for Chapter 8. On to Chapter 9, you guys.